Hey, it's Halloween season, and unfortunately, it's a little bit too cold, Frio outside. But I can get some of my favorite candies, Starburst, Skittles, and more for free. I usually get my most favorite candy of all, Circus Peanuts, around 33% of the time, but I hope to get even more this year. When I got back home, I counted all my Halloween candy. Skittles, then a little bit of some circus candy, then I got some more circus candy, then a little bit some more circus candy, then I got some licorice. I got some circus candy, a little bit more circus candy, and some more circus candy. Then I got me some Tootsie Rolls. What? Well, dang, that's 5 in a row, Mr. Pinceroni says. That's really weird. Is that normal? Not really. According to statistics, it's possible. What cool, circus peanuts are more popular now, because I got 5 in a row. Hold your horses. Let's do a simulation to find out. Alrighty, let's see. Here's an overview of the simulation process. Simulations are a way to model random behavior and estimate probabilities. They're also an imitation on chance behavior. Simulations are an imitation on chance behavior. The first step is to state the question. Are circus peanuts really more popular? The second step is to plan the process. We do this by randomly selecting 2 dice numbers and conducting many trials. The third step is to do the experiment. This means that we roll the dice in each trial. The fourth step is to conclude the results. This means that we roll the dice in each trial. Here's the first part. State. Mr. Pinceroni is going to explain it to y'all in these steps. The first step is to state the question. Are circus peanuts more likely because we got 5 in a row? The second one is to list any assumptions. Each dice roll rolls independently and occurs separately. The third one is, as I said, independent. Each dice roll is independent, so each number has an equal 1/6 chance of being rolled on. So there's no anything that's confounding the results. The fourth step is 33%. Circus peanuts are supposed to get chosen 33% of the time, so there's 2 numbers, 1, 8, that represent circus peanuts. So there's that. The third step is to plan the process. Get ready for my help, says Mr. Calculator. First part is to assign the digits. Mr. Calculator will help us roll the dice with a random int calc function. Numbers 1 to 6 will have an equal chance of being picked from the dice, from 1 to 6 from the dice. So in our calculations, we chose 1 and 8 randomly from the calculator. Woo, it's rolling. And bam, we got our numbers. The second part is to run 20 simulations. So running more trials ensures that the results follow a pattern aren't from chance. And the third part is to tally the results. What percent of trials had at least 33% of circus peanuts? The next part is to do the experiment. So Mr. Pinceroni says that we did 20 different trials or dice rolls to see if getting a 5 in a row was unusual or not. The results show that there's 5 in a row occurrences out of 20. So it gives us a 20% rate of that. So it may not be that rare. The final step is the conclusion. A 5 in a row is not unusual. This is because the 20% found from the previous step is much higher than the less than or equal to 5% benchmark for unusual data. Our simulation results are not enough evidence that the results can be applied nationwide. Our simulation results are enough evidence that a 5 in a row experience is not unusual in our community. We can conclude this from the lack of replication and small sample size from the data. This is how I roll. Mr. Calculator says, they did a team. Yeah, that's right. We learned a lot about simulations. See, what's next? We could do something for Thanksgiving. Not so fast. I'm kind of tired. I'll see myself out in. Bye.